So now I'm going to take a look at number 6, which is the integral of x squared e to the 2x dx. Okay, so I guess we can follow the Lippitt idea. Do I have a log? No. Do I have an inverse? No. Do I have a power? Yes, there's my u. Okay, so that's how you Lippitt. So I'm going to come down here. I'm going to just change color because I'm using it for this one. So this would be u is equal to x squared. So du is equal to, and again, I'll just take derivatives, 2x dx. Okay, and I'll just leave it. And then dv has got to be the part that's left over. So dv is e to the 2x dx. So now you start thinking in your head here, what's v? Right. If it's 2, it's going to come out as 1/2 e to the 2x. Okay, so again, I'm choosing this to be u and this to be my dv. And that's the starting of that integration by parts formula. So it's the same start. Everything is exactly the same. All right, so now we apply the formula. And so the formula says take u times v. Okay, so this would be 1/2 x squared e to the 2x. All right. Minus what? You subtract the integral of v du. Now again, I'm going to think in my head here a little bit, so I'm not writing all this stuff down. I'm going to take v du, these two. So what would I get if I take v times du? So it's going to be the integral of v du. So what should I write? I'll say again? X e to the 2x. X e to the 2x, and of course I got the dx. And then you might be saying, hey, where did the 2 and the 1/2 go? Okay, I'm doing it in my head. 2 times 1/2 knocks itself out. It's like if there was a negative there. If one of these was negative, what would I do in my head? I'd say, okay, negative, oh, that'll make that a positive. So you're trying to think ahead here. Okay? So now you're down to this part right here. So this is done. This piece is finished. Now I have to integrate this piece. But what do we notice about this piece here? It's another integration by parts. So what's the deal with x squared? Got to do it twice. What if that was x cubed? 3 times. So when I give this to you on a test and it's to the 10th power, guess how many times you got to do it? 10 times. Yeah. Would I do that to you? Absolutely. But I don't think some of you are working hard enough. Okay. They will never do that on the AP. The highest power you ever go to on the AP is second power. So good news there. And a lot of times it's the first power. Because they're not interested in you doing the process over and over and over. They're saying, hey, at least you can do it once. If you could do it once, you could do it twice. But it does happen, so that's why I'm going up to as high as the second power. So now I come up into this section right here. This is still here, but I'm going to work on this. Okay, so we're going to look at just this piece right here. So we'll say u is equal. We can follow Lippitt again. No log, no inverse. We got a power again, so u equals x. Du equals dx. dv equals e to the 2x dx. So v, I'm integrating on both sides. I get 1/2 e to the 2x. Okay? All right, so now we come down here. But you got to be careful how you write this now. This is where you just have to be careful. Mathematically, you have to keep everything in check. I'm going to start with this piece that I have right here. So I'm just going to bring this straight down. So this will be 1/2 x squared e to the 2x minus. Now, here's the thing. What do I need to do mathematically here to keep this all correct? Parentheses, okay? I'm actually going to set up a parenthesis here. Because remember, integration by parts is two pieces to it, and you have to make sure we understand that. So I'm going to say minus what? Minus uv. So this will be 1/2 x e to the 2x minus the integral of v du. Okay, so that's these two pieces. So v du will be, am I okay if I put the 1/2 here? See, 1/2, I pull numbers out in front. Then e to the 2x dx, that's that last part, and I'm closing my parentheses. If you don't keep the parentheses in there, the problem is going to be gone. You will not get the right answer. You're going to lose the switch in negative. And believe it or not, when they give this problem, if this problem is a multiple choice, they know the mistakes students make. They know students will forget to put parentheses. And so guess what? They'll have the choice that you make the mistake on. And you'll go, hey, there it is. Okay? Because they know that. Yeah.
Like, you have to do it twice. Or do you always want to make sure you have v equal dx?
At the end? I don't know if it'll always turn out that way, but with this kind of problem, with like an x squared, x cubed, it will. Yep. Because guess what's happening? The power went from 2 to what? Power went from originally was 2, went down to 1, then it went down to, I didn't have it anymore. So it actually went from 2 to 1 to 0. Okay? So if it was power 3, it would go down 3, 2, 1, 0. If you didn't choose u to be the x and you took it to be dv, the power would keep going up and you'd get worse and worse. You don't want that. So you always want to keep bringing the power down. Okay? All right, so now we'll finish this out. We get 1/2 x squared e to the 2x, and now I distribute, yeah? Minus 1/2 x e to the 2x, and don't get too happy and say, hey, I can combine these, because you can't. All right, they're not exactly the same. But now what am I going to write here? Okay, so I'm going to say plus. Now I got to integrate this. So I got to think. So that's going to be 1/2 from the integration, but I have a 1/2 sitting in front. So that's going to be a 1/4 e to the 2x plus c. So that's going to be your answer for that one.